Today's lesson is about simplifying or reducing fractions. Simplifying a fraction is in fact finding its simplest form, where its numerator and denominator are relatively prime. For example, 2 over 3. The numerator 2 and denominator 3 are relatively prime. Their G.C.F is 1, their only common divisor is 1. That's why this fraction cannot be simplified or reduced. We call it a irreducible fraction. So simplifying a fraction is in fact finding its irreducible form. If a fraction can be simplified like these fractions that we will simplify here in these examples, these fractions like 36 over 48, at least they have 2 as common divisor because they are both even. This fraction is called reducible fraction. We can reduce it, we can find a form of this fraction that is equal to it but with a lesser numerator, smaller numerator and denominator. So this fraction is reducible, we can simplify it. Now to simplify a fraction, we have 3 methods. Let's start with method 1, successive divisions. What we mean by successive divisions is that we divide the numerator and denominator by common divisors. For example, 36 and 48 are both even. They are both divisible by 2. I will obtain 18 over 24. Also 18 and 24 are both even. I can simplify by 2. I will get 9 over 12. And 9 and 12, they are both divisible by 3. I will obtain 3/4. Of course, I don't have to simplify only by these divisors. I can choose any common divisor that I want, depending which one I will find first. For example, 36 and 48 are both divisible by 6. For example, if you notice that 6 is a common divisor, you can start with 6. You don't have to start with 2. Maybe you can start with 6, then simplify by 2 if it's possible. So it's 6 over 8. Now 6 and 8 are even. I can simplify by 2. I will get also 3/4. So it doesn't matter with which common divisor you start first. What matters is to find the same irreducible form. We will get in the end the same answer. Now 3/4, 3 and 4 are relatively prime numbers because they are consecutive. So 3/4 is an irreducible fraction, and 36 over 48 can be simplified. It's a reducible fraction. And to find this common divisor, we use the divisibility rules by 2, 3, 4, 6, 9, and 10 that we learned already. And if you notice here, we did 3 steps of simplification. Here we did 2. The greater the common divisor that we want, the lesser the steps will be. Method 2 is prime factorization. In this method, we need to write the numerator and denominator in the form of product of prime numbers. So we decompose 36 into product of prime numbers by dividing by prime numbers, starting with 2 in case the number is even. 36 divided by 2 equals 18. 18 divided by 2, 9. Then I can by 3. 3 divided by 3 equals 1. And I decompose also 48. 48 divided by 2, 24. 24 divided by 2, 12. 12 divided by 2, 6. 6 divided by 2, 3. And 3 divided by 3 equals 1. Now I write 36 in the form of product of 2 times 2 times 3 times 3, and 48 in the form of product of 2 times 2 times 2 times 2 times 3. Now, to simplify this fraction, I just need to check the repeated factors. 2 and 2 are repeated, I cross them. 2 and 2 also. Now I can cross the 3, 1, 3, and 1, 3 from the denominator. 3 and these two 2's will remain. It's equal to 3 over 2 times 2. And then in the end, I write 2 times 2 in the form of a number. I will obtain 3/4, an irreducible fraction. So in this method, I cross the common factors, and the remaining factors I copy them, and in case there's a product of numbers, I find its value, and the obtained fraction will always be an irreducible fraction. Now method 3 is simplifying 36 over 48 by their GCF, by their greatest common divisor. And to do so, first we need to write 36 in the form of product of prime factors. 36 is in fact 2 exponent 2 squared times 3 squared, and 48 is equal to 2 exponent 4 times 3. And to find the GCF of 36 and 48, we look at the repeated factors with the smallest exponent. 2 is a repeated factor, and the smallest exponent is 2. So it's 2 exponent 2 times, and here we have 3 is a repeated factor, and its smallest exponent is 1 in fact, times 3 equals 4 times 3 equals 12. So 12 is the GCF of 36 and 48. So we can simplify this fraction by the GCF of the numerator and denominator, and you obtain also 3/4. So when we simplify by the GCF, we only have one step of simplification. Not as we did here. Here we had 3 steps of simplification. And in fact here the GCF is the product of these small divisors that we used in each step. 2 times 2, 4 times 3, it's 12. Using this method will allow you to simplify the fraction in one step only. Now let's solve this example. Simplify the following fraction. We will use method 2 and method 3. First, let's start with the prime factorization method. To simplify 35 over 105, let's write 35 and 105 in the form of product of prime factors. So here we can't simplify by 2 and 3. We only divide by prime numbers. We can by 5. 35 divided by 5 equals 7. 7 divided by 7 equals 1, and we are done. Here also we can by 3 because 1 plus 5 equals 6. If you can start with 5, it's easier. 10 divided by 5, 2. 5 divided by 5, 1. Then I can simplify by 3. Divide by 3 equals 7, and 7 divided by 7 equals 1. So 35 is in fact 5 times 7, and 105 equals 3 times 5 times 7. Now I check which factors are in common. We have 5 and 5. Across them we have 7 and 7. Now here, if you notice, we crossed both factors. So if we cross all the factors, what remain in fact is 1, because we are dividing 5 by 5 equals 1, and 7 divided by 7 equals 1, and 1 times 1 is 1. So if nothing remains, it's in fact 1, and in the denominator 3 will remain, and the answer is 1/3. Now let's simplify this fraction by their GCF. So we will need to find the GCF of 35 and 105. We already decomposed 35 and 105 into product of prime factors. 35 is equal to 5 times 7, and 105 is equal to 3 times 5 times 7. So the GCF is in fact, let's see which factors are repeated. 5 is repeated, and the exponent is the same one, so this is the smallest exponent, 5 exponent 1 or 5, and 7 is another repeated factor, and 1 is their exponent, so 7 exponent 1 is the repeated factor with the smallest exponent, and the answer is 35. So 35 is in fact the GCF of 35 and 105, and the answer is also 1/3. It's an irreducible fraction. Now let's solve this question. Find a fraction equal to 25 over 45 whose denominator is 36. So the question is in fact 25 over 45 equals to which fraction whose denominator is 36. So here the numerator is unknown, we need to find it. I ask myself, 45, how did it become 36? I need either to divide or to multiply by a number to find an equal fraction. We cannot subtract or add to find an equal fraction, only by dividing or multiplying. So 36 is less than 45, and do we have a number divided by 45 that will give you 36? No. So in this case, what do we need to do? In this case, I need to simplify 25 over 45 and find its irreducible form. So we noted that 5 is a common divisor, and we obtain 5 over 9. So we found the irreducible fraction equal to 25 over 45. Now, from the irreducible form, I deduce the answer. Now, I noted that 36 is a multiple of 9, and 9 times what equals 36? 9 times 4. So I ask myself, 9 times what equals 36 times 4? I multiply the numerator by the same number, and I find the missing numerator of this fraction. And 20 over 36 is the fraction equal to 25 over 45, whose denominator is 36.